Hey guys, I am so excited to talk to you guys. I hope you guys are watching these videos. I want to tell you I bought a tripod, so my phone is stable now, and I'm gonna start recording this video, and I'm hands-free, so hopefully this will be a little bit better for me to show you the work. And then I have some fun things coming up this week. So number 1 on Tuesday's DMR, it says, which statement below is true about an odd number? The sum, which means to add, of an even number and an odd number is odd. So we have to try the rule to see if it works. So an even number, 2, and an odd number, 3, is odd. 2 plus 3 equals 5, and that is odd. Now, B says the sum of 2 even numbers is odd. So, for example, if we did 2 plus 2, that equals 4, and that's not true. Remember, we're looking for the true statement. C, the sum of 2 odd numbers, again, sum meaning add, is odd. So, for example, if we add 3 and 3, we get 6, and that is not true. An odd number is divisible by 2. So, let's say 5 divided by 2. 5 divided by 2 would not be divisible evenly. If we did that, we would get 2.5. So, that is not true. So, the only one that's true here is A. The sum of an even and an odd is an odd. All right, let's move on to number 2. Number 2 says Joe can run a lap around the football field in 12.3 seconds. Pete can run a lap in 9.4 seconds. If Joe runs 14 laps and Pete runs 11 laps, how much longer does it take Joe to run than Pete? So I'm comparing Joe and Pete. How much longer does it take Joe than Pete? So what I need to do then is I need to figure out Joe and Pete before I can compare them. I'm going to move my scrap paper down. I hope you have the answer to number 1. So Joe can run a lap in 12.3 seconds, and he's going to run 14 laps. All right, and then Pete can run a lap in 9.4 seconds, and he's going to run 11. All right, I am not going to be able to show you my calculator screen, but since this is a word problem, you are free to use a calculator. So I'm going to figure out Joe on my calculator. I'm going to type in 12.3, and I'm going to multiply that by 14. I get 172.2, and those are seconds. I'm loving the tripod. And then I'm going to also, in my calculator, figure out Pete, 9.4 times 11 laps. Okay, so I've done 2 steps of the problem so far. I figured out Joe and I figured out Pete. And then the question says, how much longer does it take Joe to run than Pete? So in order to compare, I'm going to need to use the operation of subtraction to compare the 2 people. So I'm going to type in 172.2, which is Joe, and I'm going to subtract Pete, who is 103.4. And when I do that, I get 68.8 seconds. So he's faster by 68.8 seconds. Okay, I'm going to see if I can find that answer choice down here. I see that D matches the comparison between Joe and Pete. Okay, so I hope that one made sense. All right, number 3. Number 3 is a rounding problem. And these are the problems that I said were the backwards rounding, is what I like to call them in class. That means that we are going to try each of these numbers and see if they will round to 38.6. Okay, so let's try these first two. So if I have 38.592, I'm rounding to the 10th place. So I'm going to round the 5. I'm going to look next door. The 9 is going to bump the 5 up to a 6. So that one works. Okay, I'm going to use that same strategy for every single one. So if I have 38.618, again, my goal is to get 38.6, so I'm looking at the 10th place. I need to check the neighbor or the place value next door. The 1 is going to leave the 6 a 6, so this one will also work. Remember the rounding rule. If it's 5 or more, you raise the score. If it's 4 or less, you're going to let the number rest, meaning you're not going to change it. Okay, let me scoot over so you can see the next two. All right. Now, let me just say this right away. The goal number is 38.6. Don't mind my cat running through the house at this time. And this is a whole number of 37. And so is this one. So I'm going to say right away that these are not going to match 38.6, even if we were to round to the 10th place, because the whole number will not match. So we're not going to choose those. Okay, and then we're going to move over to our last set. So remember, goal number is 38.6. That's what it tells us we need it to be. So I'm going to line up. Everybody with me so far? I'm trying to fit everything in the screen. All right, so goal number is here. Let's look. 38.659. So I'm going to underline the 6 and look next door. The 5 is there, so the 5 would change that to a 7, which then doesn't match the number that we're trying to choose. So we won't choose that one. Okay, and then let's try this last one, 38.561. So remember, we want this to be at a 6, 38.6. If I look next door, the 6 is going to change the 5 to a 6. Because it's 5 or more, you raise the score. So this one fits. I hope that made sense, and I hope this number that they asked you to round to is guiding you as you're doing your rounding. All right, let's move over to number 4. Number 4 is a word problem, so you are allowed to use your calculator at home, okay? It says, our school wants to go on a field trip to the zoo. There are 634 students at the school. We can fit 31 students on a bus. In order for all of the students to get to go, how many buses are we going to need? So if you don't remember yesterday's problem, it was about putting chairs in rows. And in that problem, the principal wanted 26 chairs in every row. And we had to fill the rows completely. In this problem, all of our students have to go, okay? Whereas in the chair problem, once you filled up your rows, if you had leftovers, you just left the chairs, okay? But for this problem, we need to remember we can't leave any students behind. So if I have 634 students, and I am going to put 31 on each bus, if I divide out my students, then I should figure out how many buses to take. So the answer is going to be about the buses. You can't see it, but I wrote buses over here. All right. So I'm going to need multiples of 31. So 31, can 31 go into 6? Nope. Can 31 go into 63? So I know it can go one time. Let's check 2 times. I'm using my calculator as you can. So 31 times 2. 31 times 2 is 62. That's perfect because we're trying to get to 63. So 31 times 2 is 62. We're going to subtract. 63 minus 62 is 1. And then we're going to bring down the next number, which is 14. Can 31 go into 14? The answer is no. So this tells me so far that 20, and I'm just going to go ahead and write it next door here. 20 buses can take most of the students, but there are 14 students left over. If I take 20 buses, I'll have 14 students that don't fit. So if Mrs. Daniel was going to make sure we had enough buses, what would she do? Is she going to leave these 14 students at the school? Well, the problem says all of us get to go. So that means, unlike the chair problem from yesterday, 20 buses is not going to be quite enough because these 14 people cannot get left behind. So what Miss Daniel is going to do is that she's going to order 21 buses, and that 21st bus is only going to have 14 kids. So it won't be filled to capacity, but the 21 buses will allow all of us to go. So instead of the answer being 20, the answer is actually 21. And I hope that made more sense than our word problem yesterday, okay? All right, let's do number 5 together. Number 5 is asking us, I'm going to bump the word problem up, so make sure you have the answer for number 4. Number 5 is asking us to find the product. Do you remember what product means? Product means we're going to multiply. In this problem, we are finding the product of 5 and 1/4. Now, I want to show you, they did the picture for us. What they did is they drew 1/4 5 times. Now, you could, using repeated addition, you could combine these pieces together and get the same answer. So I'm going to use repeated addition by adding the gray squares together, and then I'll show you the math behind the multiplying. So let's say we need to take this 1/4 and we'll add it to the square over here. We'll take this 4th and we'll add it to the square over here. And then we'll take this 4th and we'll add it to the square over here. And then we'll have 1 left over. So it looks like we have 1 whole square and 1/4 left over. Do you see how that matches answer choice C? Now let me show you how we can get 1 and 1/4 by actually multiplying. So you will set it up with 5. It says find the product of 5 and 1/4. Remember, a whole number can be written over 1. And then when you multiply fractions, you multiply straight across. So 5 times 1 is 5. 1 times 4 is 4. Now, you may be visualizing an improper fraction right here because the numerator is greater than the denominator. So the way I think of it as, if 4/4 is 1 whole, here's our whole, how much more is 5/4 and 4/4? And the answer is 1/4, which is why our picture shows 1 whole, because 4/4 is really 1, and 1/4. So 5/4 can be written as 1 and 1/4. It can be rewritten. So improper fractions can be written as mixed numbers. And we did this in class. I just don't know if you remember that. I just want to say I just totally love you guys and I miss you so much. And I hope you guys are checking in every day. If you are not doing anything else that I have assigned, I hope that you guys are really keeping up with your DMR, because these are all the review skills that we've done all year long. So this kind of work is just keeping the things that we've learned fresh in your memory. And I know that I've assigned some newer things on measurement. Don't let those things discourage you. Just explore them. I know they're new to you, but again, it's just to get you thinking while we're not in the building together. I love you, and I will see you tomorrow. Stay healthy. Wash your hands.